dear students. Students, like every year, my student complains, ki, ma'am, okay, we are all okay with this topic, all topics of class 12, but this topic, relations and function, always create a mess to us. So we get confused how to write the solution, how to write the steps, how to interpret the whatever condition they are talking about. So, bacha, this is my promise. You watch my this video and then see कि how much easy this topic is. ठीक है बच्चा? So today we all will start the topic relations and function and we'll see how much easily you can find this topic. You can present this topic. ठीक है बच्चा? I am sharing my screen. I'm visible Ajay now. ठीक है तो बच्चा टुडे वी विल बी डूइंग द टॉपिक रिलेशन एंड फंक्शन तो बच्चा जी लेट्स स्टार्ट माय टॉपिक इज रिलेशंस एंड फंक्शंस ठीक है बेटा जी For starting this topic, beta, first we need to revise class 11th topic. Class 11th में you all studied about sets, ठीक है? Then you studied about Cartesian product, beta. Cartesian product, and then you studied about relations. Fine. Ab bacha, we'll do a small recap of these all topics because they are basic for our topic for class 12 relation and function. So what was set? So bacha, set was a well-defined collection of some numbers or functions. Fine. And what was a Cartesian product? Cartesian product was a non-empty set A to a non-empty set B such that, like if I'm taking like this is my set A, 1, 2, 3. And this is my set B. To like keep it smaller, I'll be writing 4 and 5. Fine, better. So now Cartesian product says my all possible ordered pair from A to B. That is 1, 4, 2, 4, 3, 4. Or 1, 5, 2, 5 or 3, 5. If we write this all possible ordered pair in a set builder form, in a roster form of a set, like the ordered pair was 1, 4 beta, then 1, 5, then 2, 4, 2, 5, 3, 4, 3, 5. If I'm writing this in curly bracket, that means set of all ordered pair is called the Cartesian product. It can be from any two empty set, like one empty non-empty set to another non-empty set, or it can be like from A to A as well. A to A as well means, bacha, like here also I have 1, 2, 3. Here also I have 1, 2, 3. So this is my A, this is my A. A cross A means I will be making order pair 1 with 1, फिर 1 with 2, फिर 1 with 3. ठीक है बेटा फिर ऐसे 2 with 1, 2 with 2, 2 with 3. Then 3 with 1, 3 with 2, 3 with 3. This all ordered pair will be called Cartesian product of A cross A. Okay, like Cartesian product of set A to the set A. Okay. ठीक है बेटा। अब बच्चा, after that topic was relations. What was relation? Is that relation whatever you feel you hear in daily life? Okay, this person has relation with that person like this. No, no, no. So what is that relation? Relation is beta something else in mathematics. What is this? This is somehow. But just a minute, just a minute. Here, ठीक है बेटा. So my relation was, if I'll be writing here, yes बेटा. So we are starting here. Relation is what? Relation is a subset of a Cartesian product. That means if we are talking about relation, that is from our set A to the set B, so that relation will be a subset of A cross B. Okay, now you can put this sign or you can remove, it's up to you, because this subset mein bacha, that means this relation will be a smaller part of this Cartesian product. ठीक है बेटा जी. Now up, if we talk about, like, for an example for relation, suppose for the same set A and B, if I find a relation R that is a set of ordered pair such that where y is equals to x plus 1. ठीक है. For all, this symbol is for all. X belongs to A and y belongs to B. This is set builder form of a relation. तो बच्चा, if I talk about this set builder form and I want to do कि अब इसको अगर हम लिखते हैं बेटा, तो सी अब इसमें कौन, like how many ordered pair we can include in this. So this will be Rajesh, y is equals to x plus 1. Like if I am keeping 1, so y will be 2. That is not here. If I'm keeping 2, so 2 plus 1, 3 is also not here. If I'm keeping 3, so 3 plus 1 is 4. So that means in this relation, I have only like singleton set this 3, 4. Only one of element in this set. So this is relation. So you can see, and if we see our previous A cross B for these two sets, bacha, so it was, you see, this was A cross B. So that means this R, 3, 4 beta here hai. So that means R is a subset of A cross B. ठीक है बच्चा. Or in such that in relation, whatever ordered pair we take, if by chance I am taking another example, so let's take one example so that we can talk about domain, range, and codomain. ठीक है बेटा. If now I am taking a set A, that is 1, 2, 3, but this time my set C is 4, 9, 10. ठीक है बेटा. So if we'll make Cartesian product for A to C, तो मेरा बच्चा it will be, you can make all like 1 and 4, 1 and 9, 1 and 10, then 2, 4, है ना? Like till the 2, 3, 10. ठीक है बच्चा? But if we talk about now one relation, now if we talk about one relation for this set A to B, for this set A to B, that is beta, relation is a set of ordered pair where y is equals to x square. Fine. And same condition, x belongs to A, y belongs to C. ठीक है बच्चा? Now let's make the ordered pair. अब बच्चा ordered pair में if we'll see, x square, x किस बच्चा 1 का square, 1 is not here, 2 का 2 square, 4 is here, 3 square, 9 is here. So we can consider only 2 elements. तो बच्चा roster form relation का what is that? 2, 4, 3, 10. ठीक है बच्चा? So in this if we want to write domain, so what was domain? What was domain? Domain was set of all first element of the ordered pair in relation. So that is 2 and 3. And what is range? That is second element of our ordered pair. That is 4 and 10. Okay, beta. And what is my codomain? Codomain is the complete set C. That is 4, 9, 10. So, bacha, this is, beta, this is the like previous recap of the topic relation. But now, for class 12, we will start doing types of relation. Fine. Types of relation में चलो let's start. ठीक है बच्चा जी चलो let's do now types of relation. ठीक है बेटा चलो ठीक है now fine. Now बच्चा will do types of relation. What are types of relation? So बच्चा first type is बच्चा first type if we talk about that is empty relation. And the second is universal relation. Universal relation. Right? And third is identity relation. Then three more relations, that is reflexive, symmetric, and transitive. We'll also talk about those three. That means altogether six relations we'll talk about. So first type, empty relation. Now what is empty relation? Empty relation, bacha, a relation are on a set A to B. Empty relation or a void relation if R is 5. R is 5. Fine. R is 5. What does it mean R is 5? That means if we say कि बच्चा our set was 1, 2, 3. A set was 1, 2, 3. B set was 4 and 5. Fine. If I take a relation such that ordered pair y is equals to x cube. ठीक है बेटा, वही से x belongs to A and y belongs to B. ठीक है बेटा, तो let's make the step. First of all, R is if I do cube of x, that is 1 cube, 1 is here, no. 2 cube, 8 is here, no. 3 cube, 27 is here, no. So that means I can't write any element here. Enough. So I can't write any element here. So that is R is 5. So in such case, we say a relation is an empty relation. Is this clear, bacha? Fine. And this can be a relation from a non-empty set A to a non-empty set B or from A to A. And when we say relation is from A to A, in 11th we learned, we say this condition as relation on A. ठीक है बच्चा जी, चलिए बच्चा, अब let's talk about another thing, that is universal relation. Fine. Now we'll talk about universal relation. This universal relation. What is universal relation? What is universal relation means, beta, कि when we have all elements of Cartesian product in my set of relations, that is in relation, all my ordered pair are in relation. Such type of relation is called universal relation. For example, like I am taking a set A. My set A is 1, 2, 3. And my set B is 4, 5, 6. Fine. अब इसमें क्या है बेटा? My relation is A to B. Fine. अच्छा, now if I make ordered pair, that is A cross B for this, what will be it? 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6. ठीक है बेटा. Then 3, 4, 3, 5, 3, 6. So this is my A cross B. Now, if I take a relation R such that it is an ordered pair X and Y, where Y is equals to you can say Y is greater than X. Take this relation. Okay, beta. Now, Y is greater than X if I see this relation. But all ordered pairing Cartesian pair. Everywhere my Y is greater than X. Right? That means in my relation also all ordered pair of Cartesian product will be all element of my Cartesian product will be in my relation. Such type of relation are called universal relation. Hopefully it's clear, beta. Next, move to next type of relation, that is identity relation. Third type is with the identity relation. अब ये क्या है बच्चा आइडेंटिटी रिलेशन. For an example, I have a set A, 1, 2, 3. बोलते हैं बच्चा relation is said to be an identity relation on A if R is equals to AB, R is equals to AB such that A and B belongs to A only, fine. To A only, and A is always equals to B. Okay. So, if you make for this set, so what will be it? Bacha R is 1, 1, 2, 2, 3, 3. So this is a relation on set A such that AB belongs to A and A equals to B. So in this you can say only bacha, only these like 1, 1, 2, 2, 3, 3 elements will be in this relation. See, that means all element with relate with itself only, then it is an identity relation. Okay, bacha? In this set, no other element can be there. Only this A, that is same doublet, you can say, will be there. Hopefully it's clear. Chalo. Thank you. Thank you, bacha. In my that previous video, we watched about three types of relation. That was anti-relation, universal relation, and identity relation. Now, the most important relations we'll be discussing. That first is the first beta reflexive relation. Second is beta symmetric relation. And then third is beta transitive. Transitive relation. Because the first one, reflexive relation. What is reflexive relation? So, if we use the statement, a relation from a set A is said to be reflexive if A be A relate to A relate to A. What does it mean? For all A belongs to theta, that means I have all A over there belongs to R for all A belong to A. That means beta in this, if I have a set A, 1, 2, 3. In this, I can have in A cross A 9 element. So that element, okay. But in a relation that we can say doublet must be there. 1 must be related to 1, 2 must be related to 2, 3 must be related to 3. And except then it can have another element as well. But having this doublet is compulsory, mandatory. And last, now what is the difference between identity relation and reflexive relation? So the identity and reflexive में difference is in reflexive we can have more than this relation, that is doublet types relation. But in identity, we can have only and only these elements. ठीक है बेटा? तो अब बच्चा, we can say reflexive relation cannot be identity relation, but identity relation is always reflexive relation. क्लियर है बेटा? चलिए अब इसको रिफ्लेक्सिव को like we'll understand with one more example. As like condition is there are three lines in a plane. This is R1, sorry, L1. This is L1. This is L2. This is L2. ठीक है बेटा? My relation is such that my L1 is parallel to L2. L1 is parallel to L2. Now, if I replace it as, that is, I am writing L1 is related to L2. Can I write L1 related to L1? Which means, will L1 parallel to L1? And every line is parallel to itself. So this is a reflexive relation. If a line L1 is parallel to L2, we can say relation L1 is parallel to L1. So that means A is A and A is related to R. ये मेरा रिलेशन है, तो ये दिस इज माय रिफ्लेक्सिव रिलेशन. क्लियर है बेटा? चलो अब हम बात करते हैं बेटा सिमेट्रिक रिलेशन. बेटा नाउ बेटा we will be doing questions of NCERT, then we will be understanding more symmetric relation. ठीक है बेटा? अब symmetric relation क्या होता है? तो क्या बोलते हैं? A relation R defined on a set A is symmetric if AB belongs to number, यानी AB relate कर रही है R से, which implies BA also belongs to R. ठीक है? So it means for all AB belongs to A. ठीक है बेटा? That means if A is related to B, then B must be related to A. Better. Fine? Is it fine? So, like what I'm saying? Let's take the previous one example where we were saying the relation was line L1 parallel to L2. So in this, can I say line L2 is parallel to L1? Yes. So this is a symmetric relation. Fine, beta. Like one more example will be taken for this. One example we will be taking, like triangle 1 is congruent to triangle 2. So this is the relation. That means triangle 1 is related to triangle 2. The relation is of congruency. Then we can we say triangle 2 is congruent to triangle 1? Can we say? Yes. So that means this relation is symmetric. Clear, everyone? Remember that most important relation is transitive. What is transitive? Transitive is to transfer, to move on. Like something is moving on. What does it mean? Because transitive relation means transitive relation means if my A comma B belongs to Y, such that one more B comma C belongs to Y, then the condition is A comma C also belongs to Y. In such case, the relation will be said as transitive relation. Fine. The same example if we are taking, if L1 is parallel to L2 line and L2 line is parallel to L3, will L1 parallel to L3? Yes. Yes. That means this relation is transitive as well. Transitive, and condition was if A is related to B, B is related to C, then A will be must be related to C. That it is transitive. ठीक है बेटा? तो अब बच्चा one more example of this such type of lines. We are talking about perpendicular line. This is L1. This is L2. This is L3. Okay. Relation says line L1 is perpendicular to line 2. Line 2 is perpendicular to line 3. So will line 1 perpendicular to L3? No. So that means L3, L1 is not perpendicular to L3. What it says L1, L2, belongs to relation L2, L3 belongs to relation, but L1, L3 does not belongs to relation. That means this relationship is not transferable. Clear है बेटा? ठीक है, तो अब बच्चा हम we will do few questions of these all three like all three relation types of relation where we will move to one more thing. A function is said to be, so a relation is said to be an equivalence. Equivalence relation if it is first is reflexive, second is symmetric, third is transitive. Okay, बच्चा? So a function or a relation is said to be an equivalence relation if it is reflexive, symmetric, and transitive. ठीक है बेटा? अब now we'll be doing few questions, few examples to clear this concept more. Fine, बच्चा?